Hello and welcome to the Physiology of Endurance Running podcast. I'm Owain. I'm joined by Dan. How's it going, Dan?
Yeah, good thanks. Good thanks. Nice holiday away in the Peak District, camping, uh, beautiful weather, nice run up some hills, a bit of being ill, a bit of feeling sorry for myself, but mostly good fun. Yeah, good. How are you doing, Owain?
Good. Yeah. Back into full training now. I think I have to say that I'm doubling. So,
I know I saw doubles. I've been meaning to say to you before we started recording, double days. You
yeah,
always say you can't hack that, but it's become a regular feature.
I've found the key to doubling is to actually eat food at lunch, and then
That's funny, that, isn't it?
I know. Yeah,
Yeah,
yeah.
yeah.
Dietitians everywhere holding their head in their hands.
Yeah.
Um,
Well, what I loved was that you were fun employed, as you said, had all the time in the world,
yeah.
and now he's got a job. He started double daying.
I know. Yeah. Trying to fit too much in now, I think. Um, yeah, I'm getting tired, but no, good. Yeah, doing good. Yeah, actually looking forward to some racing, and yeah, the doubling is hopefully going to lead to maybe some double threshold. We'll
Oh, he
see.
said it. He
Yeah,
said
we'll
it. Double
see.
threshold. It's coming.
So as always, we're sponsored by Saw. As Dan mentioned, I've been having to fit my running a bit around work now, and I've been doing sessions really early in the morning on a treadmill. And my saw vest especially is really good. In a garage with no fan or anything. It's about the lightest thing I can wear. Yeah,
Like
feeling
A,
really
I
good
agree
now.
with you, but B, why are you wearing a vest?
Yeah, it does come off after a while. Um, but Saw, I would say something I'm really excited to see with Saw. They have a new sort of trail racing kit. I'd heard about this maybe a few weeks ago. But it's designed to be worn with a pack, so it's got abrasion resistant material where your sort of trail running pack would normally sit. There's a really cool video on Saw's Insta with Tim, the designer at Saw, talking through basically how they designed it. It looks like, guessing he mentioned it on the video, there should be a Saw trail pack as well coming, which would be pretty cool. Yeah, they think a lot about everything else, so I'm really interested to see what the pack's like. Um,
That's cool, yeah. But because I've had that issue before. I haven't done a hell of a load of trail races, but I have done a couple. I've done the South Downs Way 50K a couple of times, and I've always just been in my club vest, a saw vest normally. Certainly last time I did it, uh, and then a race pack which covers like far more of your shoulders than the vest
yeah,
does. And
yeah.
I've never had an issue over 50K, like 3.5 hours of racing. But I think longer. It's something I thought about doing it before in the prep for it. I I don't have like a more tank top style vest either.
Yeah. It's certainly something
Mm.
you see in trail running, isn't it? And even just the fact that there seems to be two garments that are designed to go together is
Yeah,
quite nice because you spend a lot of money. Like I've got a Solomon pack that I have to wear for all the fell races, um, and then yeah, like you say, yeah, it maybe my club vest or like often I'll just go with a t-shirt because I sort of actually don't like the sort of overlap. But yeah, it's really cool to see something that's been designed to work together.
mm. I
Yeah, just
can't race in a t-shirt. I know you did at Barry for Barry 40, but I've never. I don't think I've ever done a race in a t-shirt, like ever.
t-shirt under vest for
Even if it's
cross
freezing, it's just a
country.
mindset. It's a mindset.
Yeah.
And we had a comment the other day, didn't we, from people listening saying, "I've only just realised what you mean when you say vest." One of our American listeners,
Oh
when
yeah.
what do they say? Singlet, don't they? A singlet.
Yeah,
Is
I
that what they
think so.
call it?
Yeah,
Yeah,
yeah.
we're talking about a singlet here.
I
That
think
tickled me.
t-shirt under vest. Bring it back. T-shirt under vest and sunglasses for cross country.
Yeah, is that right? Yeah. What's
Yeah,
what's Ailish McColgan's partner called? He always used to
Michael.
wear Michael Rimmer, wasn't
Yeah,
it? He always used to wear a t-shirt under a vest,
I like
regardless of the
it. I
weather.
rate
800
it.
meter guy, 143 maybe. He was good.
Yeah, I rate
But
it.
yeah, I
Big
don't think
fan.
it's a good look. I'm not bringing it back.
We've got really sidetracked. So yeah, check out Saw. Go on their Insta and have a look at the trail talk 'cause it's really cool. Yeah, them applying their normal approach to trail running, which is cool to see.
Yeah, I'll keep an eye out for that pack. I'll be putting an order. I think. Um, So, yeah. So I guess the other thing we need to say is thank you to all of those who reached out about the coaching from the Endurance Collective. Um, Fantastic response. We really appreciate everybody who sent us the information on the contact form. If we haven't got back to you, we'll get back to you very soon. But yeah, we're at capacity now. Unfortunately, there's only a limited number of slots we could take on and still do a good job. As we said, we're not just going to fill out the whole books and just mass produce stuff. That's not what we're about. I'd like to think we've got integrity and want to do a really good job, especially if you're paying a good chunk of money for a service. But as I said, we want to keep that quality really high. If you can still fill out the form if you want to and go on the waiting lists. And at some point, maybe if circumstances change, we might have a few more slots available. But at the minute, yeah, we're at capacity. Yeah, thanks again to everyone who's reached out. I think almost everybody has been emailed by now, but if not, we'll get back to you as soon as we can. Anything else there?
I think that's it. Yeah, yeah. Like you said, if you think you're still interested, like by all means fill out the form. Yeah, we'll still get back to you and yeah, keep you in mind.
Yeah, absolutely. Nice. So today we're going to talk about, well, firstly, it's quite nice. I'm quite looking forward to just you and me having a chat again, which we haven't done in a while. We've just had some really cool guests,
Yeah,
which has been great. And the reception to that has been fantastic. So I'm glad they're going down well. But it's nice just to have a chat with you on an evening, on a Wednesday evening about physiology and sports
yeah.
science.
It's
Um,
like back in the postgrad room.
exactly. Back in the Cardiff Met postgrad room. No, there's no one in there these days. But yeah, today we're going to talk about skeletal muscle, which I think people, the impression I would get, I think, if when I'm talking about the physiology of muscle, is people don't think that's very interesting. But then you start talking about it, and they go, "Oh, yeah, actually, that's really interesting." And maybe you'll get all the way through this podcast and think, "Nah, it was boring." But hopefully not. I think actually there are a lot of just interesting components to how skeletal muscle works, and actually good ramifications for how you should structure your training based upon these principles as well. So we're going to do not a super deep dive because you can go into so much detail here, and we'll save that for an expert edition of the show. But yeah, certainly like a first introduction into muscle and how it works, ramifications for endurance training in general. So I guess starting off then, there are three different types of muscle within the human body, and they are smooth muscle, cardiac muscle, and skeletal muscle. All really interesting, and have got big implications for health, but also running performance as well. So smooth muscle is the muscle that lines like our blood vessels. So our arteries, our arterioles that direct blood to our muscles during exercise, they control the size of those blood vessels, the size of the lumen, that space where blood is flowing. So if it's hot or if we're starting exercising, we're going to get a vasodilation or expansion of our blood vessels, and that's controlled by the smooth muscle. And if one of the ways we can play with this, I guess, is doing things like taking beetroot supplements, which is effectively increases the level of nitric oxide within our blood. This is a vasodilator. It triggers those muscles to vasodilate and can direct more blood flow to the working muscles. So smooth muscle, one type of muscle, really interesting, good implications for performance. We're not going to talk about that today, but just to let you know, there's another type of muscle. The other one is cardiac, which hopefully goes without saying. That's the muscle that makes up the chambers and walls of the heart. And this is like really interesting stuff in that it's almost completely fatigue resistant. Like your heart beats 365 days a year for the whole of your life. And even during extreme exercise isn't the thing that fails in most normal physiological, not pathophysiological circumstances. which is crazy when you think about actually skeletal muscle, which obviously you can feel it fatiguing. Your heart just keeps beating and beating and beating. And we don't really know why it has these properties, but it's pretty much completely fatigue resistant. So again, super interesting. Like you could spend like a whole podcast series probably just talking about cardiac muscle and the heart and the structure of the heart and how it contracts. We're today going to talk about skeletal muscle. And skeletal muscle, hopefully, is pretty self-explanatory. It's the muscles that surround our joints and enables tension and contraction around the joints. And I'm not saying movement, because we can have things like isometric contractions where we're locking a joint in place. Or if you think about like the postural muscles, so the ones around the core and the back, they hold us upright during just sitting down, listening to this podcast or running, whatever. They are enabling us to stay upright by contracting isometrically, basically. But also the obvious muscles like, the quads, the glutes, the hamstrings, the soleus, the gastrocnemius, etc., that allow movement around the joints. So that's what we're going to talk about today, skeletal muscle in general.
Yeah. So I think then when you start to talk about muscle types, maybe the thing that people do know is the sort of the breakdown of like types of muscle fiber. So this is where we're talking about like fast and slow twitch muscle fibers. Um, at some point the naming got changed. I don't know when it got changed. But yeah, anyway, so you got type. They stayed the same. Type one or slow twitch muscle fibers. Um, they're the ones we're especially like interested in as endurance athletes. And then you've got two types of fast twitch fibers. So you've got 2A and then 2X. There used to be 2B. I don't know when that changed, but yeah, or even why it changed, to be honest. But yeah,
It's like in everything. There's a million names for the same thing, aren't
yeah,
there? But you can loosely break them down to slow twitch and fast twitch. And then there's two types of fast twitch, like type 2A, or I think normally people are calling it type 2X now, aren't they?
yeah, yeah,
Um,
yeah. I think it's just like when you read like older stuff, it's then 2B. But yeah, so within those, I guess within the fast twitch fibers, the 2X fibers are like very fast contraction speed fibers, but they have like a really, really low fatigue resistance. And then 2A are still fast contracting fibers, but they have slightly better fatigue resistance. Um, and I think again, this is maybe more of an anecdote from like a lecture, but at least like sort of what I heard was, or what I remember hearing is like if you just get someone up off the couch, they actually have like a really big percentage of 2X fibers. They've sort of like never exercised, and generally doing like most types of exercise does shift towards 2A just because like the fatigue resistance profile, the 2X fibers like fatigue so quickly that they're not particularly useful for sort of most sports, I'd say.
or just day to day living and
Yeah,
surviving, and in general.
yeah. Like there isn't many things besides like sort of what like a one maximal force output that are really sort of low fatigue resistance muscle fiber is useful for. Um, and then you've got the type one fiber, which is obviously a slightly slower contracting muscle fiber and very very fatigue resistant. That's the one that sort of enables you to get through a marathon. Whereas the 2A and 2Xs are the ones that enable you to, like max squat. There's just a complete difference in sort of the demands of the muscle there.
Yeah, and I know it's just they've just got different characteristics, all of which are useful in different situations. Like you said, like a slow twitch muscle fiber is much smaller. It can't produce as much force as a fast twitch muscle fiber, but it's much more fatigue resistant, and it's got much better aerobic qualities as well. And I think one of the anecdotes or descriptions that I like is that if you look at like if you buy a whole chicken in a supermarket, obviously one ready to be eaten, the thigh bones are much darker meat compared to the wings, and that's because the thigh bones, a chicken or humans are standing up all day. There's a much higher proportion of slow twitch muscle fibers in those joints that need to be fatigue resistant, or in those muscles that need to be fatigue resistant, like the legs, because we're standing up all day. And so those slow twitch fibers have got more hemoglobin in them, more myoglobin, not hemoglobin, sorry, more myoglobin, which is like the oxygen storing system that muscles can use. They're more capillarized. There's more red blood cell. There's more capillaries going through those, supplying those muscles, and so they just appear darker. Versus the wings, which actually need to be quite fast twitch. They need to produce a lot of force and to enable them to fly. Right? And don't necessarily need to be that fatigue resistant, because chickens don't fly a long way. Not sure if that was a good example or not, but I just think that's something that's interesting. You know, we have different. I think there are different types of muscle, and they look different, but also, I guess, on that note, that even humans tend to have a more slow twitch fibers, or a higher proportion of slow twitch fibers in their legs versus they do in their upper body. In evolutionary speaking, we are built to run and to walk and be on our feet all day. Whereas our arms, they're good for fine motor skills, and they're good for throwing things, like for ballistic activities. That's what we've evolved to do. And so we don't need loads of fatigue resistant muscle fibers in our arms.
Yeah, yeah, and you can see it when if you ever like if anyone ever, if they want to, has a go at hand cycling, or like arm ergometry, and you just fatigue so quick. Like I did a study where you either did arm or leg ergometry, and like was working at a far lower power output using my arms, and basically went to fatigue, whereas with my legs just sort of like kept going. Um, yeah,
Yeah,
so it's just yeah
yeah.
interesting the sort of
Well,
contrast. Yeah,
to continue that example, like we had I was in the lab today, and we were doing a piece of work with someone from Sail GP, which is like this American Cup style racing, and he was a what you call a grinder. So they're the ones that are basically doing arm cycling to pull the sails in and out, which actually is really intense, like 10, 20, 30-second bursts of activity over the course of like an 8 to 10 minute like sailing race. And this guy this is what he's professional in this, professional grinder now. But he was also a ex-Olympic rower, Olympic gold medalist rower. And anyway, we did a VO2 max star test with him, and he was getting up to 375 watts at the end, and that's for upper body cycling. That's a norm for upper body hand cycling. That's enormous. That's a huge amount of power. But I could get to 350 watts at the end of a VO2 max test on a bike, which just shows you the difference in upper versus lower body abilities. Your endurance capabilities is just so much higher on the legs versus the arms.
yeah, yeah,
Definitely getting sidetracked now, which has
yeah,
turned into like different modes of activity. But yeah, I guess
yeah,
with key messages, but these different fiber types have got different characteristics. Fast twitch fibers, great for producing force, can contract really quickly, but are much more reliant on anaerobic qualities. And I said that slow twitch fibers have got more aerobic qualities. There's much more mitochondria within a slow twitch muscle fiber, whereas a fast twitch fiber hasn't got many mitochondria relative to a slow twitch one, but it has got a lot of glycolytic or anaerobic enzymes that allow it to produce lots of lactate and more force through glycolysis or anaerobic metabolism. And
yeah.
as we
Some
said,
others,
go
I
on.
was gonna say some other notes I just had about the different fiber types. Like a type 2X fibers has 10 times greater peak power than a type 1 fiber, and yeah, 6 times greater peak power for a type 2A fiber. So
Yeah,
like they're yeah producing sort of significantly more force, but yeah, they don't have those aerobic sort of qualities that you mentioned.
yeah, yeah. And I guess the last thing about slow twitch fibers is it seems to be, although this is a bit debated, I think I was having a discussion with Husey, and he was apparently he's done a deep dive in this, and apparently it all stems back to one old paper from the 1970s, but it's always referenced that slow twitch fibers are more efficient than fast twitch fibers, so that actually they need less oxygen to produce a given amount of force compared to a fast twitch fiber. And I think that intuitively makes sense. And everyone seems to say it's true, so I'm going to say it's true as well. But yeah, I think if you've got a higher proportion of slow twitch fibers, the chances are you're going to be more economical. And we've done a whole podcast on running economy, and we know it's really complicated. It's not just about what muscle fiber types you have, but it certainly seems to be a factor that, well, it seems to be a factor, or suggested it's a factor that the proportion of fast twitch and slow twitch fibers you have may influence how economical you are.
Yeah, yeah. Um, so yeah, I guess then what we wanted to move on to was I think a quite important idea that I think some of the features of each of the fiber types, or even just the names, like, will be known by people, but then this principle, the size principle of muscle contraction, is sort of quite an important thing to, well, I think something we really wanted to speak about on this topic, isn't it?
Yeah, definitely. Before we jump to that, I think other thing I was going to address is that there's obviously, we've said that the legs are more slow twitch than the arms, for example. But there's obviously differences between athletes as well, and I think that's commonly understood. That you have your natural sprinters and you have your natural endurance athletes, or more natural, and somewhere everyone sits somewhere on that spectrum. And some of that is definitely to do with the amount of slow twitch and fast twitch fibers an athlete has. And actually, the humans are reasonably unique, I think, in that we have very diverse ratios between different athletes or different humans. So, Usain Bolt has obviously got loads of fast twitch fibers. You don't need a muscle biopsy to tell you that. But one case study that does exist is that for Colin Jackson, who after his career was finished, they did muscle biopsy work on him to look at his proportion of muscle fibers. And if you don't know Colin Jackson, who are you? Olympic gold medalist in the 110 hurdles. He had the world record for the 60 meters at one point, I'm pretty sure, indoors. So no hurdles, 60 meters flat. Incredibly explosive, powerful. Well, he had a very high proportion of the type 2X fibers, which are going to be fantastic at sprinting, especially for the more explosive sprints like the 60 and the 100. But is also quite unique in that we seem to see that most training converts type 2X to type 2A, which is what you said back at the start, Owain. But yeah, we know that sprinters have a very high proportion of those at least fast twitch fibers, regardless of their 2A or 2X. And there are other examples of marathon runners who have been biopsied and had a high proportion of slow twitch fibers. I think for me, training is obviously going to influence this, and we'll talk a bit more about that later. But I think one example for me, which I think was one example that I've sort of, I guess it's not an example, but I've always thought this about Mo Farah when he stepped up to the marathon. Like, Mo Farah is known for his amazing finishing last lap, big kick, was fast, had obviously good anaerobic capacity. And before he stepped up to a marathon, I always thought, are you really going to be a marathon runner? You just seem to be too much on that explosive side of the spectrum. He was his best ranking in terms of his times in terms of time list was in the 1500 meters. Now everyone's running 3:29, but he ran 3:28, didn't he? I'm pretty sure. And Josh Kerr only most recently, and now George Mills has just broken his 1500 meter record. But for a long time, that was exceptionally good. And he obviously went to the marathon with some success, but he was a 2:05 guy. He wasn't a 2:01 guy.
Yeah, yeah. Yeah,
you look at other people like, for example, Haile Gebrselassie and Kipchoge and who's the last ones? That's it. Who did I say? Kipchoge, Haile Gebrselassie, Kenenisa Bekele, all of those people who have gone to be more successful in the marathon, they had much better times over 10K, but were slower over 1500 meters. And I think if you'd raced an 800, I'd have betted Mo on winning there. So
Yeah.
I reckon that, I'm just saying that I reckon he's a bit more of a hybrid athlete, not a pure, like, slow twitcher.
Yeah. Yeah.
Going down another rabbit hole, but that's what I always think. That's what I've always thought about with this muscle fiber type makeup. And obviously, it's trainable. Mo got better at the marathon, but he was never going to be a 201 guy.
Yeah. 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 So, back to size principle.
Sorry.
Sorry.
Yeah. So back to size principle of muscle contraction. Do you want me to start this one off?
Yeah. Yeah. You far away.
Yeah. So we've known for a very long time that muscle fibers are recruited sequentially. And by that, I mean, we don't recruit all our muscle at once at just a different force output. We don't go, right, I'm going to do, say I can squat 100 kilos. Right now I'm going to do a 50 kilo squat. This should be quite comfortable. I don't recruit all of my muscle mass just at 50% of its capacity. What we do is we recruit our smaller, slow twitch muscle fibers first. And as the force output requirements increase, we start to recruit more and more muscle fibers. So in running terms, because we're talking about running on this podcast, if I go out for an easy run, I don't need to recruit my type 2X fibers. I can get away with just recruiting my type 1 fibers. Whereas if I start and go past my lactate threshold, my LT1, and we're probably in that threshold zone, I might need to start recruiting some of those fast twitch, those smaller fast twitch, like 2A fibers. And now if I'm sprinting flat out, I'm recruiting every fiber. So it's additional. Even if I'm sprinting flat out, I'm recruiting every one of my fibers: slow twitch, fast twitch, 2A, 2X all together. And I think that's a common misnomer. People just think, right, people just don't think about it, or just assume that we're recruiting like our muscle fibers just submaximally, whereas that's not really how it works. And I guess to take it one step back there, like the drive to recruit our muscles happens in the brain, obviously within the central nervous system, and that gets sent down our CNS, down our spinal cord, and each neuron is associated with a muscle fiber or group of muscle fibers, and that's called like a motor unit. And so the stronger the signal down the nerves, or the more nerves that are activated, the bigger the more muscle fibers we're going to recruit. And if you want to get really nerdy, you can go, actually, because fast twitch muscle fibers are bigger, they take more of a signal to depolarize, or they need a bigger electrical signal to act upon them, more neurotransmitters to trigger them off to depolarize their membrane and transfer the electrical signal into the muscle. You get calcium signaling, loads of stuff, which is just too much detail for us to go into to create muscle contraction. But yeah, those small ones are really easy to recruit. Fast twitch ones are harder to recruit. And I think that's probably enough on physiology of how we actually recruit fibers. But that then comes into like, what are the ramifications from that, I guess.
Yeah, yeah, and I think the first one, which we've probably mentioned at different points, we definitely mentioned it last episode with Rich about S&C, is that you only train the muscle fibers that you actually recruit. Yeah, so you know, like I said, you can apply that in the context of doing something like S&C, and recruiting, the type 2A and 2X fibers. But also, yeah, when you're endurance training, yeah, you only train those muscle fibers. And I think also maybe it it's relevant when people talk about like cross training and like for runners like jumping on the bike and use slightly different muscles when you're cycling than when you're running, and you're only going to be training the muscles that you recruit, and in the same recruitment patterns as well. So um, yeah, there is that to sort of bear in mind that yeah, like for your cross training, you actually still want to be using similar muscles if that's the idea. Obviously, if you're cross training because you're injured, then different
Yeah, yeah.
yeah
I mean, cross
rules will be in
training is
place.
gonna. It's your heart doesn't know if you're on a bike or if you're running or if you're in a pool, but your muscles are certainly going to know. And like the cycling, obviously, you're using the same sort of muscle groups, but the specific recruitment patterns are going to be different. And like if I've tested a cyclist who never does any running on the treadmill, I can tell his economy is going to be awful, like, because he's just not used to those movement patterns. Even though the whole muscle, like the quad, is obviously really conditioned, it's just not in that specific pattern of force development. But I think it breaks down to the most important takeaway is that easy running is going to train your slow twitch muscle fibers, and that's fantastic. And that is one of the main attributes we want to train. The slow twitch fibers are the ones that can allow you to run a really good marathon, and even 10k, 5k, etc., where we are running at high velocities. We're not maximally sprinting. We need those. We're recruiting all of our muscles, so muscle fibers. So we need those slow twitch fibers to be really conditioned. But I think one of the suggestions is that threshold training might be a good tool because it recruits enough fast twitch fibers whilst not giving us loads of fatigue. So we are now recruiting our fast twitch fibers, but not with the same in a more aerobic fashion. So they're going to be using any aerobic capacity they have. They'll be using that. Like their mitochondria will be taxed out. I'll be using them. It's going to train a good mix of your muscle fibers. The other thing to mention with the recruitment pattern is over the course of a marathon, you're going to have to recruit more and more muscle mass to maintain the same speeds. Because your slow twitch fibers are going to start fatiguing. Although they're fatigue resistant, they're going to start fatiguing. And those type 2 A fibers that we are using, they're definitely going to fatigue even more. So even though the speed is the same and the output is the same, because we're becoming less efficient, we need to produce more force. And so by the end of a marathon, you might, although the speed is quite submaximal, you're much more likely to be using a higher proportion of your muscle of your muscle fiber types. Excuse me. Which is probably why like fatigue is not linear. Like you can go do a half marathon at marathon pace, and that's going to be hard, but the next day you'll be able to walk. Whereas if you do a day after doing a full marathon, there's a lot of fatigue there. And anecdotally, I can feel pretty good a few days after a marathon, jogging, running easy. But that first session back, I'll start and I can feel my legs are in bits still. And that's probably because I've just been jogging, not using my slow twitch muscle fibers. Now I'm trying to do a bit more intensity, add in some fast twitch fiber recruitment. And those are the ones that can be really fried because they're not built to handle that extreme nature of being recruited after running for over 2 hours in a probably pretty glycogen depleted state. So it's using fibers, but you're not not using them for their normal purpose. And again, it's another reason why you probably need to do those marathon specific long runs, because that's the only way you're going to recruit those fast twitch fibers in a way that replicates the demands of running a marathon. You can do fast intervals, but you're relying more on those fast twitch fibers' glycolytic capacities rather than their limited aerobic capacities.
Yeah, and I think maybe again here when we're talking about like implications of training, um, I don't think we've completely mentioned like the effect of training on muscle fiber makeup. So again, just some notes I had, sort of a range of findings, but generally like aerobic training sort of induces about 12 to 15% increase in the type 1 muscle fiber types. And there is at least at the time that the sort of the meta-analysis that I read was written, there was one twin study where one twin was apparently a decades long endurance athlete, and yeah, the endurance trained twin had 55% more type 1 muscle fibers than the sedentary twin. Yeah, which is probably that's going to be the best way to, I guess, control the yeah, the effect of endurance training. But yeah,
Yeah, no, they're like
that's
the
not
gold
something.
standard, aren't they? Twin
Yeah,
studies, like same genetics, but
yeah,
so it should purely be environmental, not yeah, genetic. The
mm.
changes you see or the differences you see.
Yeah. But then there's, I think in terms of the rest of the shifts, it's a bit still maybe like up in the air. What generally seems to happen is like any training reduces the 2x fibers, and then it sort of depends on what training you're doing as to whether you then end up with slightly more like type 1 or um, more type 2 fibers. And then, like, even within types of training, the types of training make a difference. So, at least in terms of like weight training, I've read one paper that sort of broke it down into like slow weight training where you're, yeah, where you're sort of, I guess you'd be like grinding out reps.
Slow movement speed,
Yeah,
so
yeah.
yeah,
Whereas if you have,
low barbell
yeah,
velocity and stuff like that.
yeah.
Yeah,
Whereas in the inverse, high velocity movements, yeah, can actually induce some 2x fibers, which yeah, sprinters would definitely want. And yeah, similar sort of shifts in sprint training as well. But yeah, I think this is maybe where we sort of we obviously bias really towards like endurance training, but as endurance athletes, it's probably where you do. This is the reason why you do want a bit of everything. Like yeah, I know they're not necessarily pure sprint training, but some strides occasionally, or like you do some hill sprints, don't you? Um,
sometimes. Yeah,
Sometimes, and yeah, and like the S and C as well. Like, there's no point us. We're not going to do it justice after last time with Rich, but yeah, like yeah, doing some S and C and actually recruiting the fibers you want to train. Um, yeah, because yeah, like I think it's a sort of old running adage that like hills make you stronger, um, but actually, yeah, recruiting the fibers that you want to train will make you stronger.
and what do you mean by stronger? Do you mean more
Yeah,
force
yeah,
production, or do you just
maximum
mean
force. Yeah,
people mean
yeah,
strong? People mean stronger, but when people say stronger,
aerobic
they
strong.
often mean
Yeah,
in endurance running, don't they? They
yeah,
often mean, oh, they're stronger in the back end of a race, which is not
yeah,
stronger at all. That's endurance, isn't it?
yeah,
Like, but that's a battle for another day, I think. But
yeah,
yeah, yeah, and like hills are good because you do recruit more muscle. It shifts the load away from the stress away from the cardiovascular system and more onto the muscular system. You need more force production to run up a hill, uh, and that's why it's nice. Doing hill sprints is a quite nice, safe way to activate muscle mass without the damage or the injury risk that comes from running on a flat. You're much more you're unlikely to pull a hamstring running sprinting up a hill. Whereas if you've not done any sprinting in a very long time and you go and try and run 100 meters flat out on the track, you could easily pull a hamstring or strain your calf. Um, but yeah, I think hills are a nice way to include some sort of fast twitch muscle fiber recruitment in a reasonably safe way outside of the weight room.
yeah, yeah. Um, did you have much more to add? I think we've covered
Yeah,
quite a
I
lot.
think I think I
I
think
think
just on that trainability thing, yeah, like it's still a little bit debated. I think on how much conversion can you have, um, but a lot of this comes down to how you actually classifying the muscle fibers as well, because there's so many different ways of doing it, and I don't think there's any debate that you can get more slow twitch like fibers or fast twitch fibers that are displaying the characteristics of slow twitch fibers, or fast twitch fibers that have now got more mitochondria in them. And it's just we mentioned it. You mentioned it before we started recording. It's actually the ability to have really good papers that are long term, because these are the changes that are going to take a long time to manifest. Like we've talked about thresholds being very trainable, they move very quickly, but changing a muscle fiber type is much more of a structural thing and is going to take probably years of training. I think going back a long way to when I was doing my master's degree, I remember that there's animal studies out there where one of the ways that you can very quickly induce muscle fiber changes is by rewiring the muscle so that the nerve fibers that normally connect to the slow twitch muscle fibers, you wire them up to the fast twitch fibers and vice versa. And actually, the change in the muscle stimulation results in actually quite quick changes in muscle fiber type. But that's only going to happen through something really invasive and is obviously not going to be good for performance. So physiologically, you can see changes in muscle fiber type. But I think in humans, it happens over a very, very long period of time. And most studies aren't long enough to see those changes. But like that twin study you mentioned, like that's a really nice example of, yeah, you definitely can have these changes. It probably takes a lifetime of training, not just a classic like 8-week intervention over the course of a university term.
Yeah, yeah. Long term changes, and then yeah, good luck getting elite marathoners to give you a muscle biopsy as well.
Yeah, but there's flaws of
Um,
muscle biopsy as well
yeah,
because the distribution of muscle fibers, slow twitch and fast twitch muscle fibers, will change depending on where you are in the muscle. It changes with the muscle depth, so more superficial, and I forget which way around it is, but there's definitely a higher proportion of fast twitch and slow twitch fibers depending on the depth of the muscle. So it's not, even then it's not perfect. You can do like MRIs. MRIs can get you an idea of your muscle fiber type if you've got the right equipment and knowledge and etc. But it's just not an easy thing to quantify, which is probably why there's not enough research on it. But um,
yeah, yeah. The other sort of note I had, just another sort of I guess myth that we've perpetuated is sort of I guess as with a lot of things in physiology, although we've presented this as three muscle fiber types, they're more on a continuum. And like one paper I read sort of said that using 1, 2A, and 2X is crude. Um, and you can't like you said with like taking a biopsy, you can't just really clearly see the three different fiber types. They are on a continuum in the same way that like thresholds are. So although we've just spent a while talking about
yeah,
very
yeah.
specific
And
types,
again, I think it depends
it's
on how you classify them because there are different
yeah,
proteins that you can look at within a muscle fiber. So they've always gone about myosin heavy chains, which is to do with the contractile elements within a single muscle fiber, and there are different types depending on the muscle fiber. But then if you look at things like mitochondrial concentration or mitochondrial density, then that is definitely more of a continuum and more of a spectrum. Uh, so I think it does come a little bit down to how you classify it. But yeah, um, it probably is. It's never as clear cut as it's made out to be, is it?
no, no,
Um, yeah, but I think key messages from today are just that. Well, I hope people find that a little bit interesting, but also you can't get away with just one type of training, even if you are doing something that's quite extreme. Like, say you're going to do UTMB, I yeah, most of the time you're going to be relying more on your slow twitch fibers. But at the end of that, you're going to be using all of your muscle fibers because your slow twitch fibers are going to be pretty ruined and glycogen depleted, which is going to force you to recruit more fast twitch muscle fibers. So, regardless of what event you're training for, you should probably always do a bit of a mix of all the types of training just to target the different muscle fibers alone, regardless of other adaptations you're going to get from that.
yeah,
Is
yeah.
that a nice little summary to finish it off?
I think so. Yeah, yeah, I think so. And yeah, like you said, this is our first deep dive. We'll see if we can find an expert that wants to come on and
A
tell us what we
superficial
got wrong.
dive. Yeah.
A superficial dive. Yeah,
Yeah.
see if someone wants to come on and tell us what we got wrong.
Yeah. Oh, a nice short one today, 45 minutes.
Yeah,
Yeah. We had a few epics recently, so it's probably good to mix it up with something not quite so heavy. So one of those easy runs you do. One of your doubles, Owain, in the
yeah.
evening.
This is a
Yeah.
double podcast. Yeah.
Yeah.
Nice. Well,
Great.
yeah.
So thanks
Thanks
for
for
listening,
chatting, Dan.
everybody. Yeah, go check out Saw. Really nice products, as always. Some exciting stuff coming out. Thanks for continuing to support the podcast. And thanks to everyone who sent us messages about the Endurance Collective and our coaching. Really appreciate it. Until next time, see you, Owain. Speak to you
Yeah,
soon.
see you later.